Okay, so hello, welcome to our first asynchronous lecture. So this lecture will be about your first exercise, which is about the determination of molecular weight by the Dumas method. Okay, so we're going to be going over the initial concepts, such as the concepts of the gas laws, and then how those led up to the ideal gas equation and the concept of ideal gases. Tapos titingnan din natin kung paano siya na-apply to the Dumas method, di ba? So mostly, this is going to be an introductory portion kasi I feel na yung introduction usually ng, at least as far as my experience goes, yung introduction to physical chemistry actually comes with gases. So I'm not sure kung if that's the case with you. I think maybe you started with thermodynamics or something. But then it's also, gases are also a good starting point towards studying physical chemistry, diba? And looking forward. So yung gases itself na chapter, I believe that it's a review. It's a sort of review into the other factors or the other concepts na na-cover nyo na in general chemistry. Kung dumaan kayo sa STEM na subjects, no? So that means you'd already have to go through gases. Tapos I'm guessing na siguro in the earlier chemistry subjects, I'm not sure about the new curriculum kasi in the old curriculum dadaanan talaga in thermochemistry, tapos dadaanan rin siya sa in general chemistry, parang basics lang ng gases, no? Doon ini-introduce yung concepts of the ideal gases. So, just an introduction, why is the understanding of the gas law important? So, sensya na, hindi ko nalagay yung why is the understanding important. Bakit ba importante na intindihan natin yung concept of ideal gases? Kasi, syempre, this is just an idealized situation, ideal gases, no? So, we'll see about that later kung bakit natin siya in-study, tapos paano natin siya in-apply to the physical world. Tapos, in particular, why is the ideal gas law significant for the Dumas method? For experimentally determining molecular weight. So, titingnan natin kung paano siya na-apply yung concept of ideal gases and the ideal gas equation dyan sa Dumas method, and then how it was conceptualized. Okay? So, at saka how we all lead up to PV is equal to nRT. Kasi yan yung pinaka-ano natin na equation. It's going to be our friend for this particular portion of our lecture. So, yung topics to be covered natin in this lesson, this asynchronous lesson over here, is the kinetic molecular theory. So this is the basic theory that these are the basic postulates that actually lead towards understanding why ideal gases were conceptualized the way they are, no? Then we're going to be going over the gas laws and then the ideal gas equation. And then, titingnan natin yung Dumas method for molecular weight determination. Tapos, paano na-apply nga yung ideal gas equation doon. Or how we modify or manipulate the ideal gas equation para makapag-serve ng purpose for determining molecular weight. Okay? The expected outcomes for this lecture is that by the end, you have an understanding of the kinetic molecular theory and how these apply to gases. Ideal gases in particular. Kasi we'll be going over some of the deviations in the next lecture on real gases. And then be able to rationalize the concept of the gas laws and how their unification led to the ideal gas equation. So, titingnan natin yung mga basic laws, which I'm sure that you've already gone over, no? Yung mga Boyle's law, ganun. We're going to be looking over those concepts, but then we're going to be looking at them at the particle level para maintindihan natin siya kung bakit ganun yung naging outcomes, no? Why this particular parameter, how this particular parameter relates to the other parameter, no? Kung inverse or direct ba yung relationship nila. And then, by the end, to understand ideal gases from the viewpoint of kinetic molecular theory. No? So, how we apply the kinetic molecular theory sa ideal gases, and then siguro as as a preview of what's to come for real gases and why there are particular deviations. Now, we're going to be looking at conditions that favor ideality. Tapos we're going to be looking as well parang preparation na din for the next lecture or the next lesson and the second exercise, which will be about real gases. And then, the application of ideal gases to Dumas' method for determining molecular weights using vapor densities. Kasi his method uses vapor densities, the determination of the weights of vapor, the weights, and then vapor densities para makuha mo yung molecular mass of whatever it is you're trying to analyze. Okay? So, starting with the kinetic molecular theory of gases. So, I guess na nadaanin na rin to, but then we'll go over those again here. So, according to the kinetic molecular theory of the gases, these are 5 postulates that state that, first, gases consist of tiny particles, they're atoms or molecules, that travel in straight lines. So, plain and simple lang siya. Tinitingnan niya yung gases, either atoms or molecules yung gas mo, and then they travel in straight lines. Ganyan yung basic premise niya. And then, these particles are so small that the size of each individual particle is negligible. Okay? So, it's looking at the gaseous particles as having no volume, diba? So so small that the size is negligible. So parang inimagine na lang nila that for ideal gases, that they don't occupy a significant amount of volume. Okay, so this will be important later in understanding the conditions that actually favor ideality. And then atomic or molecular collisions are perfectly elastic, so kinetic energy is conserved. So there is no transfer of energy during the collisions of your particles. Tapos nagiging flat lang yung energy. So yung kinetic energy ng mga particles mo is conserved, meaning, like for example, if your particles collide with each other, the collisions don't cause their speeds to alter. Doesn't cause an alteration to their speeds. Okay, so there is a conservation of energy according to the kinetic molecular theory. And then the gaseous particles are assumed not to attract or repel each other. So parang wala silang electrostatic interactions with each other. So they're thought of as particles that just float by each other without actually interacting with each other. No? Kasi ano ba yung atoms or molecules? They're made of, ano ba yung mga molecules? Diba? They're made of atoms, they're made of elements. Diba? So they're basically charged bodies. But then, under the kinetic molecular theory of gases, they're not assumed to attract or repel each other. Again, this along with the non-volume postulate, makita din natin, para maintindihan din natin yung mga conditions that actually favor ideality. So, points number 2 and number 4, so points number 2 at saka number 4, titingnan natin how those apply to the particular conditions in relation to ideal gases that where favored yung ganun na ideality. And then the final one is that the average kinetic energy of the gaseous particles is directly proportional to the Kelvin temperature. Okay, so when we're thinking of gases, in this particular case, when we're going over temperatures in relation to gases, so dapat lagi natin siya iniisip in terms of Kelvin units. Hindi natin pwede siya i-consider as degrees Fahrenheit or degrees Celsius. So the units are going to be always in Kelvin. So I see sometimes nagiging mistake ng iba is that, especially for those na, siguro for you guys in under chemistry na, alam nyo na yan. But then for those who are introduced to the subject, their first mistake is to actually use non-Kelvin units. So nakakamali ng mga calculations or whatever, especially doon sa mga gas laws, mga gas law type calculations. So yan, those are the 5 postulates of the kinetic molecular theory. So I hope na internalize nyo siya at this particular point, kasi we're going to be going over this concept or the concept of ideal gases at the particle level. Titingnan natin siya at the particle level para at least you have an idea of how it is talaga at that level, no? Kasi that's the only way you can understand it, with a proper visualization at the particulate level. And this also serves as as a very fundamental concept. So at least starting now, kasi kayo mga second years kayo, no? Chem 157.1. So at least now, nasa second year pa lang kayo, at least you start to realize, or you start to grasp the fundamentals more and more better, especially yung mga kasi need nyo yan sa you're going to be needing that, especially when you go towards the board exam. Okay? So next, the gas laws. Tingnan natin yung mga different gas laws that all led up until their unification led up to the ideal gas equation, diba? So the first one we're going to be looking at is Charles' law. So Charles' law, according to this particular gas law, there is a relationship between temperature and volume. So if we were to plot a graph like this of volume versus temperature, so let's conceptualize this at the particle level. So let's say you've got a container like this, or a reaction vessel like this, and you've got all your particles inside that particular vessel, diba? So let's consider that your container is not a rigid wall, or it doesn't have rigid walls, So what happens when we heat up what happens when you heat up the system, or when we heat up this particular vessel? So as said before in the 5th postulate sa kinetic molecular theory of gases, the average kinetic energy of your particles is directly related to the Kelvin temperature. So when you increase the temperature of your system, the average kinetic energies of your particles increases. So what happens to them? They move faster, diba? Kasi nga tumaas yung average kinetic energy. So when they start to move faster, what happens? They start to collide more with each other and with more force. And then, of course, since they're enclosed in that space, they're also colliding with the walls of the container faster and then with more energy. So ano nangyayari dyan? If your container is not a rigid container, ang tendency mangyayari dyan is that your container is going to expand. Okay? So that is the relationship between temperature and volume. It's a direct relationship. So when you increase the temperature of your system, your particles move faster, they collide with each other on the walls of the container much more frequently and with much more energy dahil nga, di ba, tumaas na yung average kinetic energy nila. And so, if the walls of your container is not rigid, particularly not rigid, di ba, it's going to expand. Okay? So, if you cool down the system, ganun lang naman din yan eh. If you go in the reverse direction and you cool down the system, what happens is that yung average kinetic energy ng particles mo, they're going to be, ano, diba? They're going to be much slower. Kasi nga, mas lower na yung temperature, so mas lower na yung average kinetic energies. So, yung tendency mangyari dyan is that, what do you call this? Mag-shrink yung ano mo. Mag-shrink yung vessel mo or container mo if, what do you call this? Yung vessel or yung container mo if your temperature is cooled. Kasi nga, your particles are no longer energetic enough in order to sustain that particular volume, no? So, you can actually see this in action. For example, kumuha ka ng balloon, tapos in-inflate mo yung balloon, di ba? When you inflate the balloon, try to put that balloon in the fridge or in the freezer. Makita mo magdi-deflate yan. That's because of Charles' law. So, that's the relationship. It's a direct relationship. So, if we were to draw the graph between between temperature and volume, it's actually going to be a straight line with a positive slope. No? Kasi it makes sense. When you increase the temperature, tataas din yung volume. All because of what we discussed over here. Okay? So that's Charles' law. So at the particulate level, I hope na ma-rationalize nyo siya, ma-explain nyo siya at the particle level na ganyan siya. Kasi that's very fundamental moving forward as we go towards the concept of real gases. Tapos why there are deviations from the ideal gas law, or I mean from ideality itself, and deviations from the kinetic molecular theory of gases. Okay, so that's the first one. So moving on, the next one is going to be Boyle's law. So Boyle's law deals with the relationship between volume and pressure. So we can see over here that there is an inverse relationship between our volume and our pressure. Pero tingnan natin kung bakit. So let's try to plot again pressure versus volume. Pero tingnan din natin siya from the viewpoint at the particle level. So let's say again you have this particular container, tapos nandito yung mga particles mo, diba? Your particles are going to be over here. So let's say for example, itong particular container na yan, kinompress natin. What if kinompress natin siya, ginawa natin mas maliit? Okay? So what happens then? What happens to the gaseous particles? So yung mga particles na nasa loob mo, initially they were closed in a bigger space such as this one, diba? Kaso lang nga, when you compress your vessel or you compress your container, nagiging mas malapit ngayon yung mga particles mo. So what happens when they're closer together? Diba? They're going to be colliding with each other more frequently. That is the thing here. So in relation to temperature, they collide more frequently. Kunyari, with an increase in temperature, as I mentioned kanina, with an increase in temperature, there's an increase in the frequency of the collisions and also the energy of collisions. But in this case, when we're compressing our compressing our container, keeping temperature constant, there is an increase in the frequency of collisions. So there's an increase in the frequency of collisions among the particles, among your particles themselves, tapos an increase in the frequency of the collisions between your particles and the walls of the container. So what happens then? So if there is more frequency of collisions with the walls of the container, that denotes a higher pressure, diba? Kasi nga pinipilit mo na yung particles mo into a smaller space by compressing your container. Does that make sense? So when you compress your container, you're forcing the particles into a much smaller space, so there's limited space for them to move. And so because there's limited space for them to move, ano nangyayari sa kanila? They start to hit the walls of the container much more frequently as compared to when they're situated in a larger volume. Diba? It's all a matter of space. Okay? So what if naman, for example, in-expand natin yan? For example, itong particular, we started with this one, diba? What if we expanded the container somehow? In-expand natin yung container. Pero yun pa rin yung ano mo. Yun pa rin yung amount of gaseous particles mo dyan. Kasi we're keeping temperature and the number of moles constant over here. So, syempre, since malaki na yung volume mo, there's much more space for them to move. So, yung frequency ng collisions nila with the walls of the container and with each other is significantly lowered. So, ano nangyayari sa pressure ngayon? Since hindi na frequent yung collisions nila with the walls of the container, the tendency niyan is that your pressure will be lowered, diba? With an increase in the volume. So, that's why inverse yung relationship nila. So, if you were to graph this particular relationship between pressure and volume according to Boyle's law, ganyan yung magiging itsura niya. Diba? At kaya here, at lower volumes, if you look at lower volumes, you have higher pressures. Diba? And at higher volumes, you have lower pressures. Diba? So that's the relationship. It's an inverse relationship. So if your pressure... So this is supposed to be what do you call this? Sorry about that. Let me go and edit that. So if volume goes down, then pressure goes up. Okay? Sorry about that. So your relationship there is that when your volume goes down, your pressure now goes up. Yeah? So that makes sense. All because of the space and then the frequency of collisions between your particles and then the walls of the container. It's all about the frequency of the collisions. So I hope then naalala niyo yung collision theory, no? Kasi that's under Chem 21. I'm not sure kung Chem 21 pa rin ba yung mga nasa Chem majors. But then I guess the knowledge of the collision theory then also helps in understanding the gas laws specifically. Okay, ngayon moving on. Okay? So now let's look at Avogadro's law. So Avogadro's law now deals with the relationship between the number of moles and the volume. So nakita natin dito, at least as far as the statement goes, that the number of moles of the gas is actually directly proportional to the volume. So let's try and rationalize that again at the particle level. So this is supposed to be n. Okay, so sorry about that. So paano natin ma-rationalize yan? Let's say for example, yan ulit yung container mo. You've got a container like that again, and you've got your particles over here. Paano kung dinagdagan natin yung amount of particles? Ano mangyayari ngayon? What happens to the volume? Kunyari, imagine na lang din natin na hindi rigid yung wall na yan. Okay? So what happens is that since you have a higher number of particles, there's going to be more frequent collisions with the walls of the container. As opposed or as compared to when itong mga gray spheres pa lang yun nandyan. Diba? Initially, yung mga gray spheres lang yun nandyan, diba? What if we added more moles? More moles of gas into the container. So mangyayari dyan is that yung tendency is that your container will actually expand. Bakit siya mag-expand? Because since mas marami na ngayon yung particles mo with an increase in the number of moles, yung frequency of collisions between your particles and the walls of the container are now more frequent. Diba? Nagiging mas frequent or mas mataas yung rate of collision nila with the walls of the container. So that means ang tendency na mangyayari dyan is that your non-rigid wall or your non-rigid container mo, your container that doesn't have a rigid wall, it's going to expand. So saan ba natin nakikita yan? In case of a balloon, di ba? Pag hinipan mo balloon, syempre, lumolobo siya, di ba? Lumolobo yung balloon. So that's the same. You're adding more air inside that particular space. So nangyari is that nag-expand siya. So that is the basic definition dyan sa Avogadro's law. Okay, so if we were to plot the graph, ganyan din siya. It's going to be a straight line because as your number of moles increases, tumataas din yung volume ng ng container mo. Yan yung tendency na mangyari. Kasi you're putting more particles into a particular space. So it's going to have there has to be a compensation somewhere. It's either going to be a compensation of volume or there's going to be a compensation in pressure. Diba? Kasi if you imagine it, let's say na lang na kunyari hindi naman rigid yung walls na yan, tapos dinamihan mo yung yung amount of particles inside that container, tataas din yung pressure, 'di ba? Kasi nga as I said, nagiging mas frequent yung collisions ng particles with the walls of the container. Okay, so in a way you could think of that also as pressure increasing, parang direct din ang relationship between the number of moles and the pressure. But then it's more applicable to the volume itself. Kasi there are others naman that are at play when you specifically think of pressure. Kasi mas, I feel na mas bagay yung Boyle's law for that particular explanation. Okay, and so the final one that we're going to be looking at is Gay-Lussac's law. So, Gay-Lussac's law actually looks at the relationship between temperature and pressure. So, kita natin dito that there is a direct relationship between your temperature at saka yung pressure mo, di ba? So, let's try to plot that again in a graph like this. And then, try natin to explain or rationalize at the particle level. So, let's say, yan ulit yung mga particles mo, di ba? You've got your particles in this particular container again. Tapos, paano kung tinasa natin yung temperature? Let's say na, as opposed to the volume explanation, no? Imagine natin that yung container natin dito rigid. Rigid yung mga walls niya. So, there's no chance for expansion. So, ano nangyayari pag tinataasan natin yung temperature? What simply happens is that, syempre, again, sa fifth na postulate of the kinetic molecular theory is that yung average kinetic energy of your particles is directly related to the Kelvin temperature. So if you increase the temperature of your system, what happens is that your particles start to move faster, diba? Again, It's the average kinetic energy. So since your average kinetic energy across the board increases, that means your particles start to move faster, and when they move faster, there are more frequent collisions between themselves and with the walls of the container. Yun yung pinaka-explanation dyan. So what happens is that, since nagiging mas frequent ngayon yung, yung interactions niya with each other and with the walls of the container, what happens is that there's an increase in the pressure. All because of the fact that there is more collisions with the walls of the container. Okay? So I hope na nag-gets niyo yan, yung particle explanation na yan at the particle level. Kasi that's important, you're able to rationalize that in the physical sense, no? And not just look at that as, parang ano lang siya, parang concept lang siya as is textbook concept. So I hope na using this particular mindset, na ma-apply niyo siya to everyday living, to your everyday living. Kasi syempre, I know, mas laro na, chemistry students kayo, di ba? At yung iba dyan, atat na pag-aralan niyo yung mga, di ba? Yung mga, what do you call this, more advanced concepts, masyado daw madali. But then, kita mo naman sa board exam, di ba? Nagkakatunga nga. Tanungin mo ng basic, nagkakatunga nga, di ba? Kasi what happens is that, yan, so consumed with learning the advanced concepts na, they tend to forget the basics. So, yun. Mahirapan sa board exam. Okay? So if we were to plot the graph of pressure versus temperature, then we get a straight line again. Kasi direct na yung relationship nila, di ba? Because as temperature increases, usually that denotes an increase in the pressure. All because of molecular motion, the alterations to molecular motion, and the alterations or the manipulation of the frequency of the collisions between your particles and the walls of the container. Kasi yun lang naman ang definition ng pressure, di ba? Okay, so that's that. Now, if we combine Charles, Boyle's, and Avogadro's observations, we get this equation over here. V is proportional to the ratio of the number of moles multiplied by the temperature over the pressure. So, kailangan natin tanggalin yung proportionality sign na yan, di ba? And to remove a proportionality sign, we need a constant. So, yeah, that's what it's saying over here. So, yung constant that they came up with is R, or the gas constant. So, V is equal to RNT over P. So we just rearrange that to the familiar format that we all know today, which is the ideal gas equation. PV is equal to nRT. So nakita pa rin natin dito, at least dito sa equation na to, that all of the gas laws are still applicable, no? Yung relationships between your gas laws are still applicable mathematically. That your, for example, your number of moles is still directly proportional to the volume. Your pressure, since they're on the same side, yung pressure and volume mo, they're inversely proportional to each other. Kasi kung inurong mo dito sa right side yung volume, it's still going to be inversely proportional. Diba? Your temperature is directly proportional to volume. Your temperature is directly proportional to your pressure. Diba? So nakita na natin na the unification of the different gas laws actually led to the concept of ideal gases with the help of the kinetic molecular theory. Diba? So nakita nyo kung paano naging instrumental yung mga gas laws studied initially in the conceptualization of ideal gases. Okay? So, syempre, later, titingnan din natin kung paano yung deviations. Paano na yung nagiging deviations from ideality pag nandun na tayo sa real gases in the next lesson. Okay? So, moving forward, what specific conditions do ideal gases work in? Okay? So, diniscuss na natin to. We were looking at it carefully from the viewpoint of the kinetic molecular theory of gases, diba? Yun yung tinitingnan natin yung kinetic molecular theory of gases. So, think back to the postulates of the kinetic molecular theory. Ano ba sinasabi doon? In particular, sinasabi kasi doon na your particles are considered to have no volume kasi nga they're so small that their size is negligible. And then, they're also considered to not interact with each other. So, ini-imagine natin yung ideal gases as particles that are not interacting. So, walang attraction or walang repulsion between them. So, where does this particular notion apply? Na wala silang, interaction. So, we can assume that they're not sufficiently close to each other. Hindi sila magkalapit. Tapos, they're very small naman din. So, no volume. So, there's no interaction between them. Under what conditions is this possible only? High temperature, di ba? When you have a higher temperature, ano ba nangyayari? Your molecules let's just disregard natin yung concept of volume muna. If you have a higher temperature, no, what happens is that your particles are now farther apart. So if they're farther apart, diba, it supports the postulate that there is no interaction between them. And also at low pressures. Kasi if you have low pressures denotes higher volumes, diba? Mataas yung volume. So a higher volume actually denotes that you have a lot more space for your particles to move. So it still supports the postulate of the kinetic molecular theory that states na they don't interact with each other. So these are the particular conditions where ideal gases work at higher temperatures and at lower pressures. In relation to the kinetic molecular theory, ha? In relation to the postulate that states na hindi sila nag-interact with each other. Okay? So I hope na nag-gets niyo yan. So titingnan natin then later paano yung mga conditions that actually cause your gases to deviate from ideality and then become real gases, no? When we enter that particular realm, titingnan natin kung ano yung mga conditions para maintindihan nyo rin siya. Para as a whole, yung concept ng ideal gases and real gases will be understandable for you. Okay? So there is no deviation from the ideal gas law or from ideality in the conditions of high temperature and low pressures for the reasons that I mentioned. Still going back to the kinetic molecular theory. So very important yung kinetic molecular theory, ha, na maintindihan nyo siya. So ngayon, moving on. Let's look at the Dumas method. So the Dumas method was actually conceptualized by Jean-Baptiste André Dumas. So he was a French chemist in the 1800s, that actually worked with determining the weight of organic substances. So this was a method, yung Dumas method was specifically a method that he used in order to get the molecular weights through vapor bed densities of organic substances. So yung mga sulfur-containing na mga compounds, mga ganon. He used this method. So he proposed a method for the determination of molecular weights by analyzing for their vapor densities. And then, this can be actually applied to a wide range of organic substances, which are generally liquids at room temperature. So, generally, yung mga organic substances natin, no, they're actually going to have lower boiling points kasi because of their interactions. I hope na remember nyo rin. So, I think, I'm not sure if you're going through now, organic chemistry, but then it's useful to know the different types of interactions that actually the different types of intermolecular attractions or intermolecular forces that are existing between your organic compounds and your inorganic compounds. Okay, so you'll understand why organic substances are generally liquids at room temperature. Okay? Bakit sila in general ganyan in nature nila. So moving over to the general steps, no? The general steps of the Dumas method para maintindihan natin siya. This is just the basic gist, okay? Doon nyo mas makikita yung pinaka steps in the procedure video, sa video procedure na nandun sa virtual classroom. So the first thing that you have to do is that you need to get some of your unknown substance or your unknown organic substance, and you have to put it inside a suitable vessel. Okay? So add an unknown to a vessel of known weight. So syempre, i-weigh nyo muna yung vessel nyo. And then you get the weight of the empty vessel, tapos get the weight of the vessel now with your unknown substance added. Okay? And then after sealing the vessel with an appropriate cover, bring the substance to a temperature past its boiling point. So yung gagawin nyo, in this case, the modified method at least, what you do is that you seal your vessel containing your unknown substance, tapos ilalagay nyo siya in a hot water bath like this one. So in this case, in a large beaker. Tapos, yung gagawin nyo is that you heat that beaker containing the water, and then that's going to heat up your vessel, diba, with the unknown substance. So you're going to have to bring that unknown substance past its boiling point. So magve-vaporize siya, diba? So yung when you seal your generally when you seal the cover of your vessel, kailangan meron siyang mga small openings para ma-expel yung air during the production of the vapor. Kasi when you produce the vapor, habang pinoproduce ng system mo yung vapor, or when your unknown substance vaporizes, kasi syempre it's going to push out the air, diba? So ngayon, after doing that, you're going to heat it up until wala ka nang makita nung unknown substance mo. Wala ka nang ma-discern na liquid of your unknown substance. So parang you're bringing it to at least past the point of vaporization, na completely siya na vaporize. But not so much, okay? And then the next thing you do is upon volatilization of the unknown, you heat a little more, then tatanggalin mo na siya ngayon from the heating bath. Then papalamigin nyo siya. Ngayon, what you will do is actually weigh the vessel. Ayan. Weigh naman na ngayon yung contents ng ano. You weigh the vessel now or you weigh the container kung saan yung unknown mo. Tapos yung new weight na yan, so just perform the necessary calculations, no? Then you get the weight of the vapor or the weight of the vapor inside your you get the weight of the vapor inside your vessel. Tapos using all the information na required or that's provided through the experiment, you can calculate for the molecular weight of your substance doing that. So this will be more understandable pag tiningnan niyo siya dun sa laboratory or sa experimental video itself. So ngayon, paano ba na-apply yung ideal gas equation to the Dumas method? So, di ba, yung ideal gas equation natin is PV is equal to nRT, di ba? So, we're going to be looking closely dito sa number of moles. Kasi technically, ano ba yung number of moles, di ba? Isn't the number of moles simply the mass over the molecular mass? Kasi think about it. Molecular mass is mass over moles, di ba? Nagets niyo? The molecular mass is, kunyari, the molecular mass of hydrogen is 1 gram per mole. So, molecular mass is actually mass per mole. So, yung relationship niya, the number of moles is going to be the mass over the molar or molecular mass. Diba? I hope na gets niyo yan. That's for the molecular weight of your substance. Again, the number of moles is equal to the mass over the molecular mass of your substance. So, i-replace nila siya dito. Substitute N for this expression over here. Then you get this. PV is equal to mass over molecular mass multiplied by gas constant times Kelvin temperature. Then just simply rearrange that, then solve for the molecular mass. So, your molecular mass now is going to be MRT over PV. O, initials ko pa. Diba? So, this is the main equation that you will be using dito sa Dumas method, no? In order to obtain your molecular mass for the unknown. Ganyan yung gagawin mo. Tapos, for this particular equation, no? Yung M, that's the mass of the vapor after volatilization. Yun yung mass na kinukuha mo after you cool down your reaction vessel. Kasi 'di ba, meron ka ng initial weights. You have the weight of the container na wala pa yung substance, then you have the weight of the container with the substance, with the unknown. And then, finally, you have the final mass of the container. So when you perform the necessary calculations, makuha mo na yung mass of the vapor. Parang yung mass of the vapor inside your container. So ano na siya? It's going to be devoid of air na. Kasi, di ba, syempre at the beginning, meron pang air yung container mo, di ba? So, the volatilization process actually pushes the air out. So at least, medyo accurate na yung mga kuha mo. In the sense na, yung vapor na lang kasi yung matitira. Vapor of the unknown na lang matitira dun sa container. So this is something you get from the experiment. And then, your P is the pressure, the atmospheric pressure in the laboratory. So this one, you will have to get this using yung applicable na laboratory instruments for that, no? So makita nyo rin yan dun sa laboratory procedure. Na mineasure nila yung atmospheric pressure in the laboratory at that particular point in time. So, if you were to do this experiment yourself, kunyari nag-face-to-face tayo and you did this yourself, you would have to determine the atmospheric pressure at that particular point in time kung kailan ka gumagawa ng experiment. Then, yung letter T, that's the temperature, it's the working temperature. So, ito yung temperature na kung saan mo binoil yung binoil yung, what do you call this, yung original substance mo, yung unknown substance. So, in case, since you're boiling the hot water bath naman, so it's safe to assume that your working temperature will be around 100 degrees Celsius. So, yan yung working temperature kasi that's where you bring your reaction vessel to at that particular point, at that particular temperature. Then yung letter V, yan naman yung volume of the reaction vessel at the working temperature. So important din yan, ha? The volume of the reaction vessel at the working temperature. So I guess here, kasi you're going to have to know the volume of your yung reaction vessel mo. So in the case of the previous in the previous slides, nakita nyo that yung reaction vessel was an Erlenmeyer flask. So dapat alam nyo yung volume niya at the working temperature. But then sometimes this may be hard to achieve kasi nga syempre yung working temperature natin kanina boiling temperature, 'di ba? So mainit. So we'd have to make a few assumptions or make a few considerations regarding that. So tingnan nyo ngayon kung bakit important din na you have to know this. Okay? So I think in the course of doing your laboratory report, may kita nyo or may explain nyo siguro kung bakit importante na you know the volume, yung total volume of your reaction vessel. Kasi you're analyzing vapor. Then vapor is gas. Gas occupies the entire volume of your container, di ba? So kaya nga kailangan natin malaman yung overall volume. But then, you have to explain bakit importante yung particular aspect na yan. Why the choice of your container is, in particular, very important for the Dumas method. Okay? Ayan, instructions for your laboratory report. So, gamitin niyo yung template na ipoprovide ko doon to create your laboratory report, no? So, may template na doon. Tapos, panoorin nyo yung procedure video na provided din sa VC. Na doon yung video ng experiment. So, obtain the data for the mass of the vapor kasi doon, you're going to get all of the information, the mass of the vapor and the other parameters such as your pressure, temperature, and volume. Tapos ngayon, after that, you have to determine the identity of the unknown. Kasi, given nandun sa video yung yung mga percentages of the elements in your the percentages of the elements in your unknown. So, you can easily determine or you can easily approximate kung ano siya. And then, titingnan mo ngayon kung whether your calculated results agree to the identity or to that particular unknown substance. And then discuss in your laboratory report the essential concepts. So, yung application ng concept of ideal gases to the method, tapos the implications din ng results nyo. If ever na may deviation siya or something, the sources of error, and then the usual stuff like that. No? So, I'm sure with this particular lecture, I think I've given you sufficient knowledge na, for that. Of the basic concepts at least in relation to ideal gases. So I hope na you guys can do your you guys can actually make your laboratory report more better, and then you can explain it more fruitfully, no? You can explain things much more better, at least at the particle level. Okay? So I'm looking for that particular explanations then. Those particular kinds of explanations are very vital kasi if you can rationalize the concepts at the particle level, it makes them so much easier to appreciate. Mas madali mo ma-appreciate kasi syempre you have a firm understanding of the basics of the basic concepts, so it's easier to apply that to living life, diba? To the physical world around you kasi yan naman talaga yung object natin dito sa chemistry. We must try there must be an attempt to not make the concepts very abstract kasi nga diba, for most of your life as aspiring chemist, you're learning about things that you can't see and feel, diba? As I said before. I don't know if I mentioned that to you. But then that is, we're supposed to be finding, we should avoid the disconnect. Okay? Kung nag-attend kayo dati dun sa How to Survive Chemistry ko, at least ma-appreciate niyo yung particular point niyan. We must avoid the disconnect between yung concepts and the physical world. Kasi, mas lalo na pag mathematical na like this one. So, introduction pa lang to the mathematical things, ha? PV is equal to nRT pa lang yan. But then we have to know that in PV is equal to nRT, there are implications. Yung relationships between your parameters, they're very important. Okay? Yung relationship in PV and RT between pressure and volume, between number of moles and volume, between temperature and pressure, and other things like that. Okay? So that's it for this lecture. So kung meron man kayong mga questions or clarifications, just send them my way on Discord, tapos sasagutin ko naman kayo agad. Okay? And with that, I'm going to be ending the lecture over here. I'm going to be seeing everyone in the next one on real gases. Doon naman didiscuss naman natin yung mga deviations from ideality. Tapos yung mga conditions that foster these deviations. Okay? With that, we end our exercise 1. So see you guys in the next lecture.